we have millions and millions of data to be analyzed. That is, it might be about hospital, it might be about engineering, it might be about different things. For example, in a hospital, which doctor is being assigned to which patient is how often a patient is being assigned to the same doctor, or what are the prescriptions and how do we analyze that prescriptions. So all of this is analysis is done using different representations, different charts, and different techniques. So in that case, there is a concept that comes into picture. That concept is called as data modeling. So a type of data modeling that is done using dimension tables and fact tables is known as dimensional data modeling. So the traditional dimensional data modeling techniques are star schema and snowflake schema. So in a star schema, a single fact table is connected to multiple dimension tables. And in a snowflake schema, a single fact table might be connected to dimension tables in which the dimension tables have subdivided or have subdivisions as minimum size dimension tables. So that is how a star schema and snowflake schema work. But as time went on, these dimension tables became inefficient for a large amount of data. That is why the advanced dimensional modeling techniques are being used nowadays. They come into picture in case of large data. So there are different types of advanced dimensional modeling techniques. So the first type could be slowly changing dimensions. It is used to analyze the data which is being changed frequently or slowly often. So there are different types such as type 0, type 1, type 2, type 3, type 4 and type 6. Type 0, type 1, type 2, type 3 are not used regularly in case of advanced data dimension modeling technique because they are used to add new rows, but they do not store the previous or the historic data. But type 4 and type 6 are used in case of advanced data dimensional modeling because of its efficient usage in storing the historic data. So let's get into type 4 SCD or type 4 slowly changing dimensions. For that, let's consider a small example. Consider a telecom. Customer plan attributes like data plan or roaming status. They change very frequently. For example, consider it changes around 3 to 4, 5 times a month. So if you consider a type 2 SCD in this case, you have to add for 1 million customers, you have to change over 12 million rows per year, you have to add them. So it becomes kind of annoying at one point. So what do you do in that case is using a type 4 SCD. That is why it is called as a silent performer. So how does type 4 SCD work over here? The thing that it uses is split it up. That is, it keeps stable data like customer ID, sign up date and time in the main dimension table, which in this case is dimension underscore customer. Whereas more frequently changing data like planning type or roaming status in a separate mini dimension table. So whenever there is a change, you can just change the mini dimension table instead of the code dimension table. So there's a small code to explain the same split it up thing that we have done over here. So the code is as follows. So here I've created a table, main code table, and here a mini dimension table storing the customer data plan and roaming status, whereas the non-changing attributes such as ID and sign up date are stored in the main dimension table. This results in 62% storage reduction and 35% faster analytics. That is why this is more efficient. Now coming to type 6 SCD. Type 6 SCD or the Swiss Army knife. It is called Swiss Army knife because it combines the strength of both type 1, type 2 and type 3. So for this, let's take a small example such as business scenario. So it is used in case of business scenario as like a business advocate has to maintain the data about the full change of history and previous values for the comparison, and it requires the current analytics in a fast and efficient manner. So in that case, type 6 SCD is used. So here you can see I've created a type table with ID, and now in the type 1 I'm storing the current value and previous value as the type 3 works, and also the versioning info, that is the valid from and valid to. So this is how a type 6 SCD works. So a type 6 SCD advantages could be it enables what if analysis. That is, what if this doctor is assigned to this patient? What happens then? So that kind of analysis can be done using a type 6 SCD. It also reduces generation time from 4 hours to 8 minutes. And complaints reports that once scan millions of transactions, now just query this one dimension. We can do that. Now, coming to another thing, that is choosing your fact table weapon. This could also be an advanced data dimension modeling technique. So, there are three, as before getting into the types of fact tables, you need to pick the right type of fact table based upon how the data behaves, how often it changes, and what question are you trying to answer. So there are particularly three types in general category of fact tables. They are transactional, periodic snapshot, and accumulating snapshot. So transactional is it tracks it like every single event. For example, consider a diary. You write it once, right? So it's for every single event. It is best for like purchases, clicks, and calls. Consider periodic snapshot. It is a summary at regular intervals, like a daily journal entry. Like for it is used for daily revenue, inventory, etc. Consider accumulating snapshot. It's like one row per life cycle. For example, take a checklist. It needs to be updated over and over time. For example, a loan approval. It needs to be updated. How much amount is being, paid for the loan. So it's like a checklist that's being updated. So these are the three types of fact table which needs to be chosen according to your data. Now, coming to the next thing is one of the other things that are being used for the advanced data dimensional modeling techniques are partitioning and clustering. They make queries blazing fast and cost effective, especially if you're using big fact tables. So if you consider over here, partitioning breaks your table into manageable chunks based on month and region. So if you're querying like sales in region west, only a small portion of the data is scanned. Like here, you could use the region and only the region area is scanned. So it definitely becomes more efficient. Similar to the clustering because they are clustered according to, that is, they are sorted according to the product category, etc. So it becomes really easy when you have to scan only a little amount of the whole wide amount of data that you have. So clustering and partitioning also helps in data analysis in that way. So query performance 92% faster and cost efficiency 40% lower scans, so it improves. So other things that are being used nowadays, but they're not being used widely, but they're being improved are bridge tables, etc. We'll come into that. So how exactly is a bridge table used? Consider a hospital. A doctor could be assigned to multiple patients, and multiple patients could be assigned to a single doctor, that is end-to-end relationship, or multiple, that is many-to-many relationship. In that case, a snowflake schema could not be used. So a bridge table comes into picture then because it helps you to track past relationships, like who was the provider for this particular patient on a particular date. So it allows you to track even the end-to-end or many-to-many relationships. The other thing that's being improved nowadays is bitemporal modeling as a part of advanced data dimensional modeling. So it helps in tracking two timelines. That is, you're tracking two kinds of time, valid time and transaction time in this case, like when the relationship was true in real life, and transaction time, when the data was entered or changed in the system. For example, it also helps in clearing the discrepancies. Like, for example, Dr. Smith was assigned to patient X on April 2 and we entered the data on April 3rd. So you can check that. And other thing that's being improved is graph extensions. So which providers share patients, which doctors form a care team. So like that, many complex networks could be there. So in that case, we could use the graph extensions or graph databases to analyze and influential patterns influence or cluster of patients which share the providers, etc. So another thing, what holds for the future of data dimensional modeling? So there are many things, such as future of data warehousing, ML-powered modeling, hash-based surrogate keys. That is, unique keys are generated automatically, real-time anomaly detection. That is, if there is any dimension change, they are caught immediately, and predictive partitioning. According to the usage patterns, queries are optimized. Another thing that's being improved is data mesh integration. That is central views for company-wide analytics. That is a team they themselves can manage their own fact tables or dimension tables, which improves the efficiency because they know their requirements. And federated engines, that is, query across domains using Presto or Trino. So, this is what the future of dimension modeling holds, and I've explained about different advanced data dimension modeling techniques, traditional dimension modeling techniques, and what the future holds for the dimension modeling techniques. That is it for this video. Thank you.